All right, we are starting task 3, the last task where we are working with quadratic functions and graphing these parabolas. But this time we're graphing them when they're written in standard form. Ax squared plus bx plus c, not vertex form, it's standard form. This form is a lot easier to find the y-intercept, but a little bit harder to find the rest of those pieces. So let's go ahead and start by first off labeling what this a, b, and c are. A is always that number in front of x squared. Right now I have a negative in front of there, so a is -1. B is always the number in front of my x, so b is 2. And c is that constant at the end, so c is 3. What I first am going to start by doing is solving for my axis of symmetry. What that does is it's telling me what my x value is in my vertex. And we use this equation right here to solve for my axis of symmetry. Negative b over 2a. So I'm going to plug in that b, right? So I have -2 over 2 times my a, which is -1. So I just plugged in 2 and -1 into the b and the a spot. And I'll solve that. -2 stays -2, but I'm dividing by another -2. -2 divided by -2 is 1. So my axis of symmetry is x equals 1. And I'm actually going to go over to my graph, and I'm going to do just kind of a dashed axis of symmetry vertically on x equals 1. That's my axis of symmetry. Now, what I can do is I know that my vertex is going to fall on this axis somewhere. And so since my vertex is going to have the x value of 1, let's figure out what the y value is. Let's plug it back into this equation. So -x squared plus 2x plus 3, I'm going to write -1 squared plus 2 times 1 plus 3. I put a 1 and those x spots in my function. And now let's solve. -1 squared is -1. 2 times 1 is 2. Plus 3, I should get 4, right? -1 plus 2 is +1 plus 3 is 4. And so my vertex is at the point 1, 4 up here. That is my vertex, 1, 4. Vertex. Vertex. Now, the other pieces of information that are going to help us make that U-shape, that parabola, are going to be our y-intercept and maybe 1 or 2 other points. We really only need 1 other point. And so our y-intercept is probably the easiest thing to find because it is just the c in my equation. So coming up here, this constant at the end is my y-intercept. Y-intercept is 3. Or actually, let's write that in ordered pairs. 0, 3, because my c is 3. So let's go ahead and graph that. 0, 3. Here's my y-intercept, that point right there. One more point that we could maybe graph is a perfect symmetry reflected over my axis of symmetry. So if I know my y-intercept is here at this point 0, 3, it's 1 space away from my axis of symmetry. And so maybe let's test and see, make sure that my other point is reflected across that axis of symmetry. What happens when I plug in 2 into that function? Do I get 3 as my answer as well? So if I were to take that equation from up at the top, -x squared plus 2x plus 3, -x squared plus 2x plus 3, and put 2 in there, -2 squared plus 2 times 2 plus 3, what does that give me? Well, I'd have -4 plus 4 plus 3, which ends up equaling 3. So if I have an x value of 2, my y value is 3, and therefore I would have this point right here, which is a perfect axis, a perfect reflection, and that can start me on my my shape of my parabola. We could also maybe plug in some points around my x-axis if I want to check those out, if I want to test and see, what my x-intercepts are. We are more than welcome to, but this is plenty for me as long as you have your axis of symmetry, your y-intercept, and at 1 reflection point with your vertex. Those are plenty to show what the shape of the parabola is. Now, a couple other little pieces of information that we could talk about. There's this question down here. Is this parabola narrower or wider than y equals x squared? Well, if y equals x squared, my a value there is 1, right? And my a value of negative x squared is negative 1. So, and this parabola has a as negative 1. And since I have a 1 and a negative 1, they actually have the same width. So same, goodness, if I can write same width. Now, if our parabola had a fraction, if a was 1/2, that's what makes my graphs wider. If a was a bigger number, like 3 or 4, that's what makes my graphs narrower. But since this parabola is just -1 instead of +1, they have the same width as our normal parent function y equals x squared. Okay, so my width is all dependent upon that a value, whatever number's in front of x squared. Since a is -1, it has the same width as our normal parent function. The second question down here is asking, does this parabola have a maximum or a minimum? Well, what do you think? Does this parabola have a maximum or a minimum? My vertex is all the way up here, so that is what we call a maximum. Maximum vertex. Just some other little bits of information. Let's go ahead and practice doing a few more of solving and graphing these parabolas. First example right here. Let's start by labeling A, B, and C. A is my number in front of x squared, which there isn't anything there, so I'm just going to put a 1. B is my number in front of x, so I'll put -4. And C is my number at the end, so I'll put -5. My axis of symmetry, remember, is that -b over 2a. And so I'm going to put, maybe I'll write this off the side, -4 over 2 times 1. And don't forget that negative in front. -b, which becomes +4, over 2 times 1, which is 2. So my axis of symmetry is 2. X equals 2. And let's go ahead and graph that. I'm going to put some dash marks. My axis of symmetry is here at x equals 2. My vertex, I know that my x value is 2. Let's figure out what my y value is. So I have x squared minus 4x minus 5. So I'm going to take 2 squared minus 4 times 2 minus 5. 2 squared is 4. 4 times 2 is 8. And minus 5, let's go ahead and calculate that. 4 minus 8 is -4. Minus 9 would give me -9. So 2, -9 is my vertex. Let's go ahead and graph that point all the way down here to -9. My y-intercept comes straight from my c value, -5. So my y-intercept is at 0, -5. That's right here. And that one more point, let's go ahead and see where we cross my reflection point over here. It's 2 spaces away from my axis of symmetry, so it should be at 4, -5. Let's go ahead and test that out. What do I get when I put 4 in for the x value? Well, I'm going to have 4 squared minus 4 times 4 minus 5, and that will give me 16 minus 16 minus 5, which is -5. So yes, that's one more point. That would be perfect to make my U shape right there. And that is my problem. Let's do another example. Number 2. Maybe I should even squeeze this in a little bit more. A, B, and C. A is 3. B is -6. and C is 1. My axis of symmetry, negative b over 2a. Negative b over 2a would be negative 6 over 2 times 3. So I'd have a positive 6 over 6, or in other words, 1. My axis of symmetry is x equals 1. So I'm going to go ahead and draw my axis of symmetry straight up and down my line at x equals 1. And since axis of symmetry is 1, I know my x vertex is 1. So let's go ahead and plug 1 into everything up here. 3 times 1 squared minus 6 times 1 plus 1. So in other words, I have 3 minus 6 plus 1. Or in other words, 3 minus 6 is negative 3 plus 1 is negative 2. 1, negative 2, which is right down here. 1, negative 2. My y-intercept is at a positive 1. My c is positive 1, so my y-intercept is at 0, positive 1, which means that my one other point reflected across should be at 2, positive 1. Let's see what happens when I plug 2 into that equation. 3 times 2 squared minus 6 times 2 plus 1. So I have 3 times 4 minus 12 plus 1. In other words, 12 minus 12 plus 1, which equals 1. So 2 comma 1 is my other point, which makes that nice little U shape. It's small, but it's still there. Parabola. Last example, number 3. Go ahead and write down your A, B, and C. It should be negative 2, negative 8, and positive 2. My axis of symmetry is that equation negative b over 2a. So I have negative 8, and 2 times negative 2. So I got a positive 8 on the top and a negative 4 on the bottom. So my answer, 8 divided by negative 4, is negative 2. My axis of symmetry is negative 2. And my vertex will then start with negative 2. Let's plug the rest of it in there. Be careful with those negatives. So negative 2 times negative 2 squared minus 8 times negative 2 plus 2. This negative 2 squared, negative 2 times negative 2 is a positive 4. So negative 2 times positive 4. Negative 8 times negative 2 is going to become a positive 16 plus that 2. Negative 2 times 4 is negative 8. Negative 8 plus 16 is a positive 8 plus 2 will give me 10. So my vertex is at negative 2, 10 up here. And my y-intercept is at 2, 0, 2. My c value is 2. Let's maybe try and find that one more point. This is 2 points away from my axis of symmetry, so my other point should be over here at negative 4, 2. So let's maybe plug in negative 4 into that equation. Let's do some negative 2 times negative 4 squared minus 8 times negative 4. Go ahead and take a few minutes to solve that one. Negative 4 times negative 4 is 16. If I multiply that times negative 2, I should get negative 32. Negative 8 times negative 4 is a positive 32. And of course, if I add 2 to that, I'll get my answer of 2. So yes, my axis of symmetry should work out perfectly. All right, those are all of your examples. I know this was a long video, but you just have these 3 problems to complete today.